Okay, today I thought we'd talk about this pedal that you can build. It's called the Fat Blaster, and it's based on some early circuits I used to do back in the late 60s and early 70s. Basically, you have a mixer. You have your fundamental tone as a square wave. You have the fundamental tone, then it's been times 2, in other words an octave up. You have the fundamental tone divided in half, which would be an octave down. And then you have the fundamental tone, which is divided by 3. For example, if you're playing an E, then it'll produce an A, which would be more than an octave down, because you're dividing this frequency by 3. Then I went ahead and after I made this simple version, I added a knob up here, which would, instead of taking the fundamental and dividing it by 3, I'd take the times 2 and divide it by 3, so it wasn't so low. So now it's just an A below the E that you're playing, as an example. And then for the fun of it, I thought, well, why not go ahead and, even though I didn't add a knob, let's put a position on the little switch here on top that divides by 5. And in this case, because that would be more than 2 octaves below, that's too low for anything usable when you're putting a guitar in as your signal, I take that off the times 2 one to get the divide by 5. So basically, what you've got, all the knobs are up a little bit right now. So that's what you've got when they're all mixed a little bit. But let's take it one by one so you can actually see what we're talking about. So there's the fundamental square wave. I'm playing high up on the neck, around the 12th position fret, because things are going to be dividing down for the most part. But let's just go ahead and go through. Here's what the times 2 one. So that's your octave up, then your octave down. And then a divide by 3. So if you start mixing these, just take the octave down and the divide by 3. We could add the 2 octaves, or the fundamental. And the only thing we didn't really talk about, so I say I take the divide by 3. Right now it's dividing from the fundamental, so that's the lower one. If I can divide it off the octave up, or if I go all the way over to the divide by 5, basically that means if I play a high E, it's going to play a C, which gives you some really strange tones. Back to the divide by 3. And so, there you have it. The Robot Hot Fat Blaster, and depending upon response to the video, I'll tell you how to build it if you want or not. It's a fairly simple build. Originally, when I built these, mostly back in the 1970s, it was almost all transistor technology then. Chips were just, integrated circuits were just becoming available at places like Radio Shack and stuff like that. This particular one has been upgraded to using the new FET that I talked about in my Axe Blaster project, and it's also using some CMOS divider chips. It can be all built discreetly, completely out of transistors. Clear back in 1967, the Gibson company, they had their Maestro series of effects, for example, and they made a rhythm and sound Maestro box, which did This is back in 1967, before any integrated circuits. All transistor technology. It would play a bass line where they filtered it off your guitar signal. It would had all kinds of filtering and stuff. This particular one, I didn't add any sort of filter to it to give them tones or anything. It's just the raw signals. Filters are something that you could add to it later. One thing to note though also is that in the bypass, I don't know if you'll be able to tell a difference in the level, because the camera is going to try to compensate for, you know, they have compressors on their microphones. So if we take that riff, as you can see, I'm just barely 1/3 of the way up on the level. I mean, it can really crank up. But be all that as it may, I think that's the end of this video. Based on response, I'll then decide whether it's worth my time to do the build video. It's not a hard build at all, and the jfets that I'm using, again, won't be jfets that any of you have probably ever worked with before, but they're very common. They're found in small condenser microphones, which are found in almost anything that has a microphone these days. I mean, from your old cordless phones at home, you can find these in the garbage. You can find these at swap meets. Tear them apart, get the mic out of them, strip the mic down. Any toys that might be sound activated, greeting cards that record message and playing back, they'll have them. Plus, you can just buy the particular jfet when I give you the number in bulk from China and get like 50 of them for $10 or something. They're very inexpensive. The advantage to using the jfet over the old transistors is you don't have to do any special biasing. You just ground reference the gate. They do the internal biasing already. They have a 110 dB signal to noise ratio, and one FET will give you about a 10 dB gain stage. Stack two together and you have 20 dB gain stage. So inexpensive, small, very quiet, so much quieter than the old transistor circuits, and very simple to use because you don't have to do any fancy biasing or anything. Anyway, that's it for this one.